Hello everyone, I'm Drago, and in my last video I made a redstone circuit that simulated an electric circuit, but today we are gonna make it better by adding battery consumption. This was my battery, and it is not really realistic, so we are gonna rework it, and we are gonna add as well as a resistor and the possibility of getting an electrical overload. And so let's start. Oh wait, first this was my battery. This was the switch, and this was the lamp. This worked, but it wasn't really realistic. If I use it, it turns off, and I use it again, it turns on. And then, now, yes, let's make a new one. This is the start of the battery we are doing. This is called a redstone clock, because when we set this here, a redstone signal is sent and it goes all the way here. And yeah, we're gonna use this as battery, or at least as the timer, which says when the battery is consumed or not. Alright, this is what I have come up with as battery. This is a redstone clock, as I have explained it there. And so when we press the button, right now it has battery, the lights are on, and the redstone clock is going. And then when it's finished, this piston pushes the redstone block there, and this piston retracts this redstone block, which is like pretty much the main battery, which right now it's simulated as not infinite battery, and the lights turn off. And so yeah, then we press the button again, there is battery. Once again, lights are on, redstone clock is going, and yeah, this is what I have come up with as the battery. This works also, this button, it goes here, the signal underneath the battery, and it pushes this piston for this redstone block to be placed here, which resets the battery. Yeah, this is the battery I have come up with. Now I'm gonna try and do the resistor. Alright, this is what I have come up with as resistor. It pretty much makes the signal lower, so when we press here and the battery goes, this makes it so the signal is lower. But if we set this is the signal is higher. As we can see, there's a difference, but the lamp is still on when this is. And yeah, it's pretty simple. And now the last thing that we gotta do is the possibility for the circuit to get an electrical overload. This is pretty much if the lamp gets, in this case, the signal too high, then it will not turn on because it will have broken, let's say, because this is how in real life this works, electrical overloads. And so yeah, let's get to it. And finally, this is what I've come up with as the overload. It pretty much works by when this is on, Right now the lamp is on, and it depends on the resistor. If there is no resistor, so we place that one there, it breaks, and now it will not work, and it will reset every time the battery is off. And so now, if we take it off, right now it works, because the redstone signal doesn't go as far as getting here, because when we press the button here, then this one we can see that it makes particles like those, but this one doesn't. This means that this redstone is powered, but this one is not. So right now we can put this here to say that there is an electrical overload, and so when we put that there and we press the button, the lamp goes on, and this actually reaches there. We can see that there are particles up to here as well, like those, and so the thing breaks. And this is why resistors are very important in circuits. They protect the light here, so it will not break. And yeah, this is the circuit I have come up with. I know it can get a lot better, but this is what I have made. I hope you'll like it. Let's give it one last go, and there we go. As we can see, it works. We can turn it off and on whenever we want, and yeah, it works. Thank you so much all. Thank you so much, and see you next time. Bye.